Vocabulary for 7.3 Angle-Angle Similarity. Similar figures. Figures that are the same shape but different size. The angle-angle similarity postulate says if two angles of one triangle are congruent or equal to two angles of another triangle, then the triangles are similar. Example 1. Explain whether the triangles are similar. The figures show only one pair of congruent angles. Find the measure of the third angle in each triangle is the first step. So they added 45 plus 100 plus the measure of angle A has to equal 180 because all triangles have 180 degrees. 45 plus 100 is 45 plus the measure of angle A has to equal 180. When I subtract 145 from 180, I get the measure of angle A is 35 degrees. And they did the same thing for the second triangle. 100 plus 35 plus the measure of angle B equals 180. 100 plus 35 is 135 plus the measure of angle B has to equal 180. When I subtract 180 minus 135, I get the measure of angle B is 45 degrees. So because two angles in one triangle are congruent to two angles in another triangle, then the triangles are similar. Now you try. Finding missing measures in similar triangles. While playing tennis, Matt is 12 meters from the net, which is 0.9 meters high. He needs to hit the ball so that it just clears the net and lands 6 meters beyond the base of the net. At what height should Matt hit the tennis ball? This is Matt, is 12 meters from the net, and he wants the ball to land 6 meters from the net. The net is 0.9 high, so how high must he hit the ball? Similar figures are proportional. So AD is to AB as DE is to BC. So 6 plus 12 over 6 equals 8 over 0.9. 6 plus 12 is 18 times 6. Multiply both sides times 0.9. And then multiply times 3 and you get 2.7. And this is how we normally solve proportions if you're more comfortable with this. 6 plus 12 is 18 is to 6 as H is to 0.9. We would add those to, this should be a 12. 12, we would add those together and then we would cross multiply. So I would get 6H equals 16.2, divide both sides by 6, and H is equal to 2.7. Get the same answer, different strategy to get there. Either way. Okay, you try. Okay, Rosie and the wheelchair ramp. I set up my proportion 24 over 8. 2 is to H. I cross multiplied. 24H equals 16. Divide both sides by 24. Get 2/3. And the lower cable meets the tree at a height of 6 feet. So this part right here is the 6 feet. And extends out 16 feet from the base. So this bigger triangle is 56 is to 16 as H is to 6. 16 times H, 56 times 6 is 336. Divide both sides by 16. And H is equal to 21, so the tree should be 21 foot tall.